Yes.
My name is SubodhCheM,
Yes.
and I live in South Chব্বিশ পরগনা in West Bengal. And from where I completed my schooling, and I completed my graduation in chemistry from Rohada Ramakrishna Mission Vivekananda Centenary College at 2015, and I completed my masters from IIT Madras at 2017. I qualified for NET exam 2 times, 2016 and 2018, and I have a research experience for 5 years, and I submitted my thesis. Thank you.
Yes, good. Today topic.
To a chemistry topic, coordination polymer.
Yes, let me start coordination. Yes, what is coordination chemistry?
Coordination chemistry is the branch of chemistry where discuss about the coordination compound, and the coordination compound is the mainly when a compound is formed when the metal is coordinate to the ligand or negative charge. The ligand may be positive, negative charge, and neutral also, and it is donated the lone pair or negative charge to the metal and form a coordinate bond and form the coordination complex.
What is coordination complex? A coordination compound.
Coordination complex is the mainly mononuclear, and it is and is coordinate with the coordinate bond is formed with the ligand. But coordination compound is maybe a polynuclear or a mononuclear also.
Yes. What is Werner theory? What is the purpose of Werner theory? What is the application, principles, limitations of Werner theory? Explain one by one.
Werner theory mainly inapplicable for the coordination compound, and it is the establish the bond between coordinated bond, and for the he chooses the one complex, and for cobalt ammonium chloride complex, and here the cobalt ammonium and chloride composition is different and in different compound, and here the he shows the in first compound is cobalt NH3 4 whole 6 and Cl3, and in this compound we added the some silver nitrate. It's three mole of silver chloride each appear, but in for this case and similar molecular formula, and it reduced the two added the silver nitrate 2 mole of the silver chloride, and similarly 1 mole of silver chloride also after the for this third complex, and from this is conclusion that the in few complex first complex the coordinated bond of this cobalt is for ammonia, and 3 chloride molecule is the outer sphere, and similarly 2 chloride molecule in the second complex is outer sphere, and 1 chloride molecule in for this third complex is outer sphere, and the remaining complex is the coordinate bond chloride ligand and ammonium ligand coordinate bond is the cobalt complex, and from this is we calculate the primary valency also and secondary valency of this coordination compound, and this only limitation is the theory is the only applicable the coordination complex, and from this theory you cannot predict the which complex is complex cannot the beyond the magnetic property and spectra of this is of this coordination compound. From this theory we cannot discuss.
Yes. What is the difference between primary and secondary valency?
Primary valency is the valency of this is mainly depend on the metal charge, it is primary valency, and secondary valency is the mainly is the coordination number, uh, which molecule which molecule is coordinate to the metal. This is the coordination number, and this is the called secondary valency.
Yes. What is the limitation of Werner theory?
Werner theory only applicable the coordination complex, and from there we call the coordinate bond, and from this theory we cannot predict the color, we cannot predict the magnetic moment of this complex.
Yes. What is ligands? How many types of ligands? What is the purpose of ligands in coordination chemistry? Can you explain one by one?
Ligands are mainly the negative charge or containing lone pair which donated the uh, electron density to the metal center, positively metal center, called ligand. A ligand mainly is two types. One is the neutral ligand and one is the charge ligand. Charge ligand is mainly is the negative ligand, and few cases is the positive ligand also, or like plus also is remain.
Yes. EDTA hexadental ligand. Can you explain how to these one represent hexadental ligands?
EDTA means ethylene diamine tetraacetate, and this is the six coordinate ligand, and this also called electric ligand, and here the six site is available to the nitrogen donating site is available, and four is the carboxylate site available, and from this site total six side, and six side we coordinate the metal and bond and form a chelating complex, chelate complex.
Yes. What is symmetrical and unsymmetrical bidentate ligand? How to define?
Symmetrical and unsymmetrical ligand.
Yes.
Symmetrical ligand is the ligand have the coordinate site is available, and one or more coordination site available, and this coordinate site if a coordinate from the one side at it may be the equal with the if coordinate to the other side, and it's a symmetrical, and from this complex it's symmetrical like carboxylate ligand, different type of carboxylate ligand, and the asymmetrical ligand is the mainly available in asymmetric site is available here, and this is the different type of ligand center, different type of ligand center present in this site. This is the DMG. DMG is the one asymmetrical ligand.
What is macrocyclic ligands?
When a molecule is macrocyclic and molecular weight is higher, and it is the more coordinate site available in this is ligand, and it is coordinate to the metal through the defined coordinate site, the macrocyclic ligand. This is the example of the macrocyclic ligand is 222 krypton type ligand. Krypton ligand.
होमोलैप्टिक एंड हेटेरोलैप्टिक कॉम्प्लेक्स क्या होता है? कॉम्प्लेक्स लिगेंड्स.
Homoleptic complex is the complex if formed the same type of ligand form the complex with combination of the same type of ligand with the defined metal, one or more metal complex. And heteroleptic is the defined type of ligand is combination is from this complex.
Yes, good. Next, move on. And IPSC nomenclature. What is IPSC nomenclature and what is the purpose of the nomenclature in coordination chemistry? And what is the application of IUPSC nomenclature? Can you explain one by one?
IPSC nomenclature is the standard nomenclature, and from this we from this nomenclature we conclude that the name of this compound, and we from this nomenclature in coordination complex we can determine the name of this complex, and from this nomenclature we also known the oxidation state of the metal, and it and forming the ion of this coordination complex also known from this is complex, and from this all over this we can know from this primary valency and secondary valency also from this nomenclature.
Yes, what is the limitation of IUPSC nomenclature?
For the very big molecule, big macrocyclic molecule, or like protein molecule also, it cannot determine the nomenclature from this IUPAC nomenclature.
नोमेनक्लेचर को क्यों लाया गया है, मतलब लाया क्यों गया? व्हाट इज द पर्पस ऑफ दिस वन इन कोऑर्डिनेशन केमिस्ट्री?
For the specific name of this compound, and from this nomenclature we also known the oxidation state of the metal.
Nomenclature is a main purpose is IPSC is a naming of the compound, identify which name is this mono, di, tri, tenta. Yes, amines, carbonyls. The founder
Yes.
of naming IPSC nomenclature. Yes.
Yes.
What is isomerase?
Isomer is the same molecular formula, but the different type of combination is different, and different type of orientation also different. It's called isomer.
Yes, good. What is the difference between structural and stereoisomer?
Structural isomer is the isomer where the functional group is different, but stereoisomer is the atom connectivity same but different spatial arrangement in 3D or 2D also.
Yes, good.
Atom connectivity same.
Yes. How many types of structural isomery and how many types of stereoisomery? Can you explain one by one?
Stereoisomer, structural isomer is the different type of structural isomer in coordination comfort. That's like the coordination isomer, linkage isomerism, and coordination isomerism, linkage isomerism, ionization isomerism. Another is the hydration isomerism also. And the for the stereoisomer here the mainly is the optically active stereoisomer, optically inactive stereoisomer, and this is the form of this optical isomer is the mainly is the P and M nomenclature also included for this. R and S also included for this stereoisomer nomenclature.
Yes, good. What is the difference between ionization isomerism and hydrate? What is the difference?
Hydration isomerism is the molecular formula frame, but in the coordination sphere, coordination in between the coordination sphere, number of water molecule is the defined. But in ionization and ionization isomerism, here the coordination sphere here also defines, and if it is ionized, then form the defined ion and form like cobalt NH3 whole pipe Cl and 2 Cl is the outer side, and similarly the 1 Cl is the inner side, and another compound also formed is 2 Cl is inner side and 1 Cl is outer side. This is the ionization isomer. And it is the similar to the hydration isomer, but here the different ion is formed in solution phase. But in hydration isomer, only water is formed. Only water.
Yes, good. What is the difference between linkage and coordination isomery?
And linkage isomerism is mainly is the when is the two different ligand, two different donating site is available in the ligand, and this from this donating site they can donate the metal center. This is the one type is the example of this ligand is NCS. It can donate the metal center through the N and also sulfur also, and two isomer is formed. And coordination isomer is the isomer here the coordination sphere of the isomer is changed. And this is an example of this cobalt ammonium 4. This is the one coordination sphere, and another is the chromium water chromium Cl4, and this is the cobalt is coordinate to ammonium and chromium is chloride. But in changing this, the ligand side is cobalt is coordinate the chloride, and chromium is coordinate to ammonium. This is both are the called the coordination isomer. Coordination sphere is difference in both cases.
Yes. What is the difference between ligand and polymerization isomery?
Ligand and polymerization.
Yes.
Ligand is the mainly donated to the negative charge or donating their lone pair to the metal center is called ligand. And polymerization is the if it is from a polymer and from using this ligand and they can in this polymer the polymerization process they can act as the linker and they also coordinate and do two or more different sites is available for this linker and they can coordinate the metal answer and form the polymer, and this process is called polymerization of this coordination polymer.
Yes, good. What is the difference between coordination isomerism and coordination position isomerism? What is the difference?
Coordination isomerism is the coordination sphere is the defined to different and different coordination complex, and coordination positional isomerism is the position is defined. This is the if coordination position is defined. This is the one example of the facial and meridional isomerism.
Yes, good. What is the difference between optically active and optically inactive compound?
And one optically active compound is the compound when it is the show the optical rotation, and it can define it as a, and if a molecule possesses the sigma symmetry, it can optically possesses the sigma symmetry, it can optically inactive, and if it is not sigma symmetry is present or I is not present, this is called the optically active compound.
Any limitation of isomerism?
Limitation isomerism. Limitation, I don't know.
Okay. Any uses of human life? What is the beneficial of each one in human life?
In define isomer and from this coordination complex and from show the defined color and defined property color or defined property also. This is the applicable in this life, and isomerism the and few cases the optical isomerism, and it is one type of the geometrical isomerism. This is the cis isomerism and trans isomerism, and this is the cisplatin. This is the cis isomer, and this is the used in the which in this cisplatin is the binding with the DNA, and this is the for use for the cancer therapy also. Cisplatin, but not transplant.
Yes, good. What is the difference between inorganic isomerism and organic isomerism?
Inorganic isomerism is the mainly situated in the coordination sphere, and their isomerism, they can the structural isomerism or the different type of optical isomerism is present, and from the structural isomerism we have it can be ionization isomerism, linkage isomerism, coordination isomerism also. And for this organic isomerism, it is the mainly situated in the optical isomerism, and otherwise another isomerism is the functional group isomerism. That the organic isomerism, the functional group of this molecular formula is the same, but functional group is the different. This is a dimethyl ether, and ethanol is the one is the example of this. This is the organic isomer.
Yes. Yes, good. Next, move on theories. Here. Theory is called metal ligand bonding in complex. Yes. What is the theory's role in coordination chemistry? Like to what is the difference in valence bond theory and MOT?
Valence bond theory is the mainly the observed have the sharing of the electron or between metal and ligand, and from this bond, this is the valence bond theory. And from this valence bond theory, we can predict the complex structure in an tetrahedral or hybridization. Also, we can determine this valence bond theory. And the M.O.T. theory is the this is the modern theory, and this from this M.O.T. theory you also predict the hybridization and coordination space structure, and also we predict the spectra and the many different magnetism also. And this is the and another theory is the crystal field theory, and this crystal field theory also predict the magnetism structure and low spin high spin complex of this coordination complex.
Yes, good. Any limitation of valence bond theory?
And from the valence bond theory, we cannot predict the spectra, color, and magnetism of this coordination compound.
What is the difference between valence bond theory and CFT? Explain briefly.
In this valence bond theory, metal is mainly sharing the metal, and ligand is sharing the electron, and form the valence and bond, and for this coordination complex. And this bond is mainly is covalent bond as from the according to valence bond theory. And this and the hybridization of this complex is determined from this valence bond theory, and is the for this if the choose the higher field ligand, and this in that cases the strong field ligand, we in that cases the um, pairing with the energy, and internal hybridization of this from unit is the internal orbital use this complex. And for this octahedral complex is the hybridization is the mainly for the cobalt 3 plus complex is the D2sp D2sp3. But in this quick field ligand, this is the outer field complex, and this hybridization is the sp3d2. And from this valence bond theory, we cannot predict the color and magnetization and spectra also. And in CFT is the crystal field stabilization energy. In this energy, have the mainly ligand is the choose the point charge, and metal is the choose the cationic pieces. And this is the purely electrostatic interaction, and from the coordinate bond, and from this, if the metal d orbital is have metal mainly for the transition element, and have the d orbital, and in if it is the metal d orbital is the spherical field, so their energy also, the spherical ligand field, their energy also higher. And from this, and d orbital is the different size shape and different size, and d z square orbital and dx square y square orbital is the oriented in the axial position, and in the dxy dy and dzx is the in between the axis. And for this in point in the axial position dz square and dx square y square, it is the more repulsive force with this ligand electron negative charge. That's why their energy is the higher. And for the another three element of three orbital of the orbital, is energy is lower for octahedral complex. And from this we calculated the crystal field stabilized energy, and the gap between the if the gap between the dx x or yz or zx and dx square y square z square is the octahedral stabilization energy, is del octahedral. And the for the strong field ligand is the pairing energy. Strong field ligand pairing energy is the lower, and for this, and del octahedral is the higher. For this they can pair up, and for this the weak field ligand they can weak field ligand pairing energy higher, and del octahedral is the lower, and they can from the electron is the jump to the higher orbital. And similarly the tetrahedral complex also, and if I have the tetrahedral complex as energy, mainly the ligand is oriented with the metal with this between axial and position, and that's why the ligand energy of d orbital of this dx or dz square is higher, and dx square y square and dz square is lower. And from this we calculated the del del tetrahedral also. And from this all this theory calculate the spectra and magnetism property is diamagnetic or paramagnetic. We can predict this theory.
Yes, good. Next is, what is the difference between LFT and MOT?
In ligand field theory, we are mainly choosing the d orbital, and have the we show the d orbital interaction and d orbital interaction. And for this the MOT we can choose the all orbital, and it is the T2 GEG A1G also. And different type of interaction is the total interaction is shown in the MOT.
Yes. What is the limitation of CFT?
Limitation of shift is the have the one spectrochemical series is present, and from this where we the taking the have the higher strong field ligand is to weak field ligand, we can predict the spectrochemical series. And in few cases is the shown that we cannot predict the which ligand is the act as a strong field ligand than other ligand. We cannot predict. And it is CFT only applicable in the transition metal only, but another metal is not applicable.
What is adjusted crystal field theory, ACFT?
I don't know.
Adjusted means pro, advance. Yes. What's the role of electrochemical series in coordination?
electrochemical series, we can situated the ligand in the strong field to weak field ligand. And first, strong field ligand is mainly the pi acceptor ligand, and in between is the sigma donor, and the next is the pi donor ligand and weak pi donor ligand, and weak pi donor is the mainly weak field ligand also. And from these electrochemicals, we predict the strong field or weak field system, and from this we predict the magnetism, we predict the octahedral crystal field stabilizer energy also, spin also, magnetism. Yes.
What is the difference between sigma pi and sigma donor pi acceptor and pi donor?
Pi acceptor means the CO, and this is the ligand also called pi acceptor, and it can the donated the ligand first low electron density, and from this metal orbital metal electron is metal donated the electron density to the ligand uh, ligand pi star orbital, and this called the pi pi acceptor ligands. And sigma donor ligand is the mainly only the donated the electron density to the metal ion, and the pi donor ligand is the only donated their pi loosely bound pi electron into the to their metal system.
What is the difference between say, tetrahedral, octahedral, and square planar complex?
In octahedral complex have the dz square and dx square orbital is the oriented with the axial position, and because of this the more electronic repulsion with this orbital, and their energy it will be higher, and dx square and d square and dz square energy is higher, and dx z y z and energy is will lower, and from this gap we can calculate the octahedral splitting energy, and from octahedral splitting energy is the additional energy for this system stability. And for this in this tetrahedral system, the ligand oriented with this coming from this the in between the in between this axis between this axis, and from dx dxy dz zx and dyz they can in between these axis, and this they can repel each other is more than the dx square and dz square, and that's why the dxy zx energy will be higher than dx square and dz square. And in alloys tetrahedral complex is the most time is the high spin complex, and this energy gap in between tetrahedral complex is the lower, and octahedral cases is the energy gap is the higher, and del octahedral equal to 4/9 del tetrahedral equal to 4/9 del octahedral. And for this square plus complex is the extreme position of this is z out complex and there is the if the in extreme condition z out complex is